Okay, good afternoon. In this video, I will be discussing further the uh, idea of using Excel in uh, solving LP problem. I'll be considering here several examples involving the case where we have minimization, the case where we have uh, three variables, the case where the functional constraints are of mixed type, like we have uh, equality type and greater than or equal to type, and also the case where you have greater than or equal to type and less than or equal to type for the uh, LP problem. So let's consider this one first. Last meeting, I already illustrated the idea when we solve this first maximization problem here. Okay, so the idea is to set up the LP problem in Excel. Like you have here the decision variables, the solution where the solutions will be placed here. Okay, and then the objective function value and the coefficients, then your constraints. So corresponding to this, let's indicate the coefficients for the objective function. We have 40 corresponding to x1 and 50 corresponding to x2. You remember we solved this already in our class using the simplex method, right? Then the first constraint has 2 and 3 coefficients respectively. Then the 30 there should be placed on the RHS, that's the right hand side. Okay. Then 1 for the second constraint, 1, and 12 on the right side, 2, 1, and 20 on the right hand side. Okay, then after that, we're going to find the objective value by multiplying the value of x1 to our coefficient 40, then add it to the product of the value of x2 to the coefficient 50. But there's a shortcut to this. You can just write the sum product, okay, function. So equal sign, then sum product, then parenthesis, then select the place, the cell where we want to indicate our solution. That's the value of your x1 and x2, then comma, and then select the coefficients. Okay, then close parenthesis, enter. Okay, and then for the LHS or the left-hand side, that refers to the value of the left-hand side of your functional constraints, considering the value of your x1 and x2 and the coefficients here. So again, you use the sum product equals sum product, parenthesis, then select the value of your x1 and x2, comma, and then the coefficient for your constraint number 1, then parenthesis, enter. Then same for this one here. You may want to copy this formula in constraint number 1, but the problem is this will automatically adjust. In other words, if you will not do something and you copy that right away, the value of your x1, x2 will be adjusted here in B18 and C18. So if you really want to copy that, then you may just enclose that with $sign, the B and the C. Okay. Ayan. Then enter, and then you can now copy this for constraint 2 and constraint 3. Okay. And then you have also to indicate whether what type of functional constraint you have. That's to guide you in when you use the solver later. So we use greater than equal because your functional constraint is greater than or equal to type. Okay, having set that up, we now determine the solution to this LP problem. Okay, just click the data. Diba, last meeting I already instructed you how to activate the solver. No? So click the data. Then if the solver is already activated, then you can see that here on the upper right of your screen. So click that solver. Then on this dialog box, you're going to erase that one first. Okay, indicate the set objective. The set objective is actually this objective value here. So select that. Then choose which one will apply in your LP problem. Is it maximization or minimization? Since our LP problem here is minimization, then we select min. Okay. Then on this part of the dialog box, by changing variable cells, you're going to indicate your value of your x1, x2, no? Yung the place where you're going to put the value of your x1 and x2. So select that, okay, and also the other one. Then go to subject to the constraint. To avoid confusion, you can first erase all of this here. So select, then delete, then select, then delete, select, then delete. And after that, click add. We're going to indicate now our constraints. Now, you can see that your constraints, functional constraints, are of the same type. They are all greater than or equal to type. So just select all of them. You can put them simultaneously because they are of the same type. And then here, you're going to select greater than or equal to, no? Kasi your functional constraint is greater than or equal to type. So choose that one. And then constraint refer to the right-hand side, the value on the right-hand side. So select that also. Okay, then click OK. Yan. And take note also of your non-negative constraints, no? So we don't forget to check this one. In this case, I already checked this, make constraint variables non-negative kasi you have non-negative condition. Then after that, you know, by the way, you need to select pala, no? The default here is simplex LP. So, but be sure that the simplex LP is selected, not the other method, okay? Because we're using simplex method. And then after selecting that, you click solve. Okay, and then it says here, solver found a solution. So there must be a solution, then click OK. And you already have here the value for your x1 and x2. You remember that we have the same value when we use the simplex method, right, in our discussion. Okay. Let's try another one. This time, we'll be considering the case where you have three variables in your LP problem. So there are three decision variables. Again, set up your Excel so that you can indicate the coefficients there. So the coefficient of x1 is 3, x2 is 1, x3 is 2. Okay. And then we have two constraints, no? Both are less than or equal to type, so no problem. We have 1, -1, 2, and on the right side we have 20, and then we have 2, 1, -1, and on the right side we have 10. Okay, and then the objective value, so this is less than or equal to type. Parehas sila, less than or equal to type. Then your objective value we'll again use the sum product, then parentheses, and then select the cells where you want your solution to be displayed. Okay, then comma, select the coefficients, close parenthesis, then enter. Okay. Also in the LHS, equals sum product, parenthesis, then your solution, comma, then the coefficients, close parenthesis, enter. Now you may want to just copy that, but don't forget to put $sign. But if you don't want to be bothered with putting $sign there, then just type formula for that particular constraint, no? Sum product, parenthesis, then here the value of your variable, then comma, then your coefficients, then close parenthesis. Okay. Oops. What happened? Oh. Let's do that again. So sum product, then the value of your variables, comma, then the value of your coefficients, a second constraint, then parenthesis, parenthesis, then enter. Yan. Okay, after that, we now go to data, then solver, and then dito, erase muna natin yan, then replace that with the objective value, this one, right? And then select maximum. A while ago, did we select minimum? Kasi minimization pala tayo kanina, no? Let me go back to that. Here, solver. Yeah, we selected minimum kanina. Okay, so no problem. So for this one here, go to solver, then we select max, E4, right? E4 muna dito sa set objective. This is where the value of our objective function should be displayed. Then max, because this is maximization, right? And then by changing variable cells, that refers to the cells where you want your solution to be displayed. And then constraints, let's delete that one first. And then click add. Okay, then sa cell reference ninyo, take note, that refers to the left-hand side. Yan. And then for this one here, both are less than or equal to type, so that's less than or equal to na. Constraint, the right-hand side. And then, okay. And then, let's check again. So, unconstrained variable na negative, then LP, simplex LP, click solve, and we have the value. So the value of your x1 is 0, while x2 is 40. Also your x3 pala. Your x3 is 30. So that's the solution to that LP problem. Let me next consider this particular case here. This is maximization, but you will notice that the functional constraints involve greater than or equal to an equality. Okay. And also it is indicated here that your x1 is unconstrained, meaning it's okay if your x1 is negative or positive, no problem. It is unconstrained. So what we will do now is, again, set up this. So you have one, the coefficient, you have 1, 1 for the coefficient of your x1 and x1. Sa constraint natin, we have 1, then 2. We have 2, then 1. Right side, we have 10, we have 2. Then I indicated here equal sign for the first constraint, right? Kasi equal siya, tapos greater than or equal to type. Objective value, that's equals sum product, parenthesis, then the cells for your solution, comma, the cells for your coefficient. Okay, then parenthesis, enter, right? The LHS equals sum product, parenthesis, then the cells for your solution, comma, the cells for the coefficient, close parenthesis, enter. Also this one equals sum product, the cells for your solution, comma, and the cells for your coefficient, parenthesis, enter. Okay, after that, we now go to solver. So data, solver, this, let's, so objective function natin ito, no? Yung nasa D17, right? Then maximization again, by changing variable, let's delete this and replace that with the cells where we want the solution to be displayed. Then the constraint here, let's delete that one first. Delete, then click add. Now this time, the constraints are of different types, so you have to do it one by one. No? For cell reference, that would be the LHS of the first constraint. Then instead of less than or equal to type, equal to, we'll replace that with equal sign. And then on the right side, we have this one, 10, okay? Then click add, because we still have to add constraint 2. So click add, and then for cell reference naman this time, so second constraint, select the LHS for second constraint, then replace this one here. This is greater than or equal to type, okay? And then constraint, this one here, right? Then click OK. Ayan. And then we can remove this check here, right? Kasi x2 can be, x2 is unconstrained. So you can remove this one here. Okay. I mean, x1 pala is unconstrained. So remove that. And then simplex LP, then solve. Now, don't worry about the warning here, because this simply tells you that when you sketch the graph, it appears that it will not converge. But there is a solution actually. No? There's a solution. When you click OK, you can see here that you have a solution for x1 and x2. So you see that x1 being unconstrained can assume a negative value. Okay? Yeah. Last. Okay, for this one, maximization ito, no? But again, the functional constraints are of mixed type. We have less than or equal to and greater than or equal to type. So the same idea. Okay, we have 5, we have 4. No, we don't put it there, but rather on the coefficients. We have 5, we have 4, and then here we have 2, we have 1, we have 1, we have 1, we have 1, we have 2, we have 20, 18, 12, and then objective value equals sum product, parenthesis, then the cells for our solution, comma, the coefficients, parenthesis, enter. Also this one here. This is equals sum product parenthesis for our solution, comma, then coefficient parenthesis, enter. Second constraint equals sum product parenthesis the solution, comma, the coefficients parenthesis, enter, then equals sum product the solution, comma, the coefficients parenthesis, enter. After that, we now set up, or we now use the solver, so data solver, and then let's erase that one here, replace that with the value here, no, in D3, maximization pa rin, changing variable. Let's select this cells here, right? Then for constraint, let's delete that one first. Delete that one. And then after that, click add. Okay, so sa cell reference, we're going to put the left-hand side. Now, we can just copy all of them, kaya lang, they're of different type. So what we'll do is copy simultaneously or put simultaneously the first two constraints because they are of the same type. Parehas sila less than or equal to, no? And then less than or equal to, then the constraint, select on also the first two constants on the right hand side. Then add, click add kasi meron pa tayong natira na isa. So click add. Then for the last one, we select this. And then this now is greater than or equal to type, right? And then select the constant on the right hand side, then click OK, right? So you have this dialog box. Now, I forgot to indicate here the non-negative constraints for x1 and x2, no, but this should be non-negative. That's why we have to select this one. Make unconstrained variables non-negative, then simplex LP, then solve. Okay. So solver found a solution. So click OK. And we have the value. Your x1 should be 2 and x2 should be 16. That maximizes the value of the objective, and the maximum value actually is 74. Okay, that's the maximum value. Yung mga previous natin problem, ito, this is the maximum value, this is the maximum value, tapos ito naman, this is the minimum value, no, for the objective function. Okay, so I hope this helps. Thank you and God bless on your preparation for the test.